in 10.2, we're talking about sum and difference identities. These are new identities. And so we're not going to spend our time proving them. We're just going to use them. It's not something that you need to memorize. You'll be given a formula sheet pretty much anytime you ever need these. One takeaway is cosine is a function. And you cannot say cosine A minus cosine B. That is not allowed because cosine is a function. We're talking about two angles and the difference between two angles. So we're going to be using these properties here. We've got properties for cosine, properties for sine, and properties for tangent. And we're just going to use those to rewrite some functions. All right, example 1 is all about cosine. So we're using our options for cosine, the sum and difference. So if I'm looking at 15 degrees, I need to think about two of them that I know values for, and can I use them by adding and subtracting to make 15 degrees. So when we do this, the first thing we want to think about is our special right triangles. We always want to be coming back to those. So we have the first special right triangle that I think about, the easy one that's half the square. It's the 45, 45, and 90. And so what that was is if these two sides were 1, and using the Pythagorean theorem, then the hypotenuse is the square root of 2. So that's one of them. And then the other one was the 30, 60, 90. So it looks like this, where this is the 60, this is the 30 up here. What that said was if the hypotenuse was 2, we cut it in half, that makes the side 1. And then this is the square root of 3. I always come back to those special right triangles when we're doing this. They help us build a unit circle. We don't ever have to memorize these things. So essentially I'm looking at these angles that I know some stuff about, and most of the time when we build these, we're looking at 30, 45, and 60. And we need to think to ourselves, how can I make 15 degrees with adding or subtracting? So you're going to think, what combination of angles can we make 15 degrees with? Well, we're showing that to be adding, so we know it's going to be a subtraction. So pick two angles that we can subtract with to give us 15 degrees. All right, there's more than one option. There's lots of options when we do this. We can do 45 minus 30, or we can do 60 minus 45. It ends up being the same no matter which way we do it, so I just take my smallest angles. So for A, I am going to write cosine 15 degrees is the same thing as cosine. I'm going to say 45 degrees minus 30 degrees. And so what we're doing is we're going to look then at that formula, and it says cosine A cosine B plus sine A sine B. So I'm going to write that out. So I have cosine 45 cosine 30 plus sine 45 sine 30. And we're going to get the values from our special right triangle. So cosine and sine of 45 degrees is 1 over root 2, so 1 over square root 2 plus 1 over square root 2, and then I just need sine and cosine of 30 degrees. Cosine of 30 degrees from our special right triangle is root 3 over 2, and sine then is 1/2. Notice these are going to have a common denominator. Again, this is why I don't ever simplify radicals. When we solve problems, look like we're going to end up with square root of 3 plus 1 over 2 square root 2. And I honestly would just leave it that way. That's the exact value for cosine of 15 degrees. If you put that in a calculator and you put that complicated fraction in there, you would get the same answer. So that's really nice. All right, let's look at B. So 5 pi over 12. And so these ones that are in radians are going to be a little bit harder. Again, we're thinking about addition and subtraction possibilities. And we're thinking about, how do I make 5 pi over 12? So we're thinking about our benchmark angles and how do we put together a 5 pi over 12. I'm going to list my benchmark angles in radians. So I have pi over 6, pi over 4, and then we have pi over 3. Now these are all in 12s. Notice 12 is the common denominator here, so I am going to come right underneath them and put them in 12ths. So I have 2 pi over 12, I have 3 pi over 12, and I have 4 pi over 12. So we're going to say, how do I make 5 pi over 12? So I happen to see that 2 plus 3 is 5. So we're going to do an addition one with this one. So I'm going to write for B, cosine 5 pi over 12 is the same thing as cosine. We're going to say pi over 6 plus pi over 4. And again, we could have done this with subtraction. It's no big deal. We could use add or subtract any of those angles as we want. I tend to just use our benchmark ones that are in the first quadrant. It's easier. I don't have to deal with signs. So the next thing I'm going to do is I'm going to just write out that formula. It's cosine A, cosine B, now it's minus. So the cosine ones are really easy to memorize. The plus and minus just flips. So I'm going to write cosine pi over 6, cosine pi over 4, minus sine pi over 6, sine pi over 4. So we know the cosine inside of pi over 4. Pi over 6, again, is that 30 degrees, so we can get those numbers from the one that we just did. So we're going to end up with 1 square root of 3 over 2, 1 over square root 2, minus, then we're going to have 1/2, 1 over square root 2. So we end up with literally the exact same thing. There's just a minus between them. So we're going to have square root 3 minus 1 over 2 root 2. That is the exact value. And that should make sense. One of them we're adding, one of them we're subtracting. So there we go. Right. Question C. For question C, now we're kind of going the other direction. So we're going to look at this. Does this look like cosine add the angles, or does this look like cosine subtract the angles? Right, hopefully you indicated that they are adding. Notice there's a minus between them. You've got cosine, cosine, sine, sine. So this is really the same thing, C, as cosine 87 plus 93. So cosine 87 plus 93 is cosine 180, which equals, hopefully you indicated -1. Good job. Right, in example 3, we're going to do the exact same thing we did, only now we're using the sign. So we're adding and subtracting right here using the sign for problem A. So we're looking at, how do I make 75 degrees? So again, I'm looking at those 3 basic ones that I always try to use first. And how do I make 75 degrees? Hopefully you indicated that 30 plus 45 is 75 degrees. So for A, I'm going to say sine 75 is equal to sine 30 plus 45. And we're going to just use the formula they gave us. So adding, I'm going to say sine cosine, and then cosine sine. So we're going to say sine 30 cosine 45, and we're going to add then cosine 30 sine 45, and we're going to use those special angles to determine what they are. So I end up with square root of 3 over 2, 1 over square root 2, plus 1/2 square root 1 over square root 2. So it's adding, it doesn't matter which order they come in as long as you do the cosine, sine of both of them. So we're going to end up with square root of 3 plus 1 over 2 root 2. So this is pretty easy to work with. We're going to do the same thing next with tangent. We got to figure out, how do I make 7/12? So again, we're looking at our list in radians. How do we make 7/12? All right, hopefully you said the 3 plus 4 right here makes 7/12. So we're going to change the way we write tangent. Okay, so we put in that 7 pi over 12 is the same thing as 1/4 plus 1/3. So now we're going to take our tangent formula they gave us for sum and difference. It says tangent A, so tangent pi over 4 plus tangent pi over 3 over 1 minus tangent pi over 4 tangent pi over 3. We're going to replace those values and simplify. So tangent pi over 4, that's easy, that's 1. So we're going to say 1. And then tangent of pi over 3, if we go to our special right triangle, pi over 3 is 60 degrees, so tangent is square root of 3. So 1 plus square root of 3 over 1 minus, tangent pi over 4 is 1, so again, I'm not going to worry about it. So then I have 1 minus square root of 3. So that is the special value that they are asking for. And the last one, we need to identify, are we adding these two angles or are we subtracting? So it's sine, cosine. There's no tangent, so it's not the tangent one. It's going to be a sine one. Is that 160 plus 40? Or is it 40 minus the 160? Which one is it? All right, hopefully you indicated that this pattern looks like the subtraction. There's a subtract between them. So this is the same thing as sine 40 minus 160. So it's the same thing as sine negative 120. So this is the same thing where we're going to look at that idea that sine is an odd function. So it's going to be the same thing as negative sine 120. And 120 is a 60-degree angle. If we think about our unit circle, it is a 120 degrees is a 60-degree angle in that second quadrant. Sine is the y value, so it is positive there. So looking at sine of 60 degrees right here, sine of 60 degrees is root 3 over 2. So we have a negative root 3 over 2. And that's how we do that.